Let's use the figure to solve each inequality. Up first, f of x is greater than g of x. Recognize that f is the red quadratic and g is the blue line. First, we're asking where is f greater than g? In other words, where is f above the g function? So that's going to happen in two different places. First, here, f is above g, and on this piece, f is above g. And the answer is going to be in terms of x values. So this region, in terms of x values, is negative infinity up to negative 2. And then we also have 1 to infinity, again in terms of x values. Part B is very similar. This time it's asking where is f greater than or equal to g. That means we can now include those intersections, negative 2 and 1. So we'll have negative infinity to negative 2 with a bracket, union, bracket the 1 to infinity. In part C, we're asking where is f less than g. In other words, where is f below the g function? And that's in this region. Here, f is below g. And our answer is in terms of x's. So that's starting at negative 2 to positive 1, excluding the endpoints due to the strict inequality. Part D is very similar, but we can now include the endpoints, those intersections, because we have equality. So we'll go from negative 2 to 1, including those endpoints. In this example, we start by asking where is f greater than g? In other words, where is f above the g function? That's going to be in this region. Again, f is the red quadratic. So in terms of x values, we're going from negative 3 to positive 1. We use parentheses because we're not including those endpoints due to the strict inequality. But in part B, we now have greater than or equal to. Still, f is greater than or equal to g. So it's the same region. We can now just include those endpoints. So we have bracket negative 3 to 1. In part C, we're asking where is f less than g? In other words, where is f below the g function? And that's going to occur in two places. Here, f is below g, and here, f is below g. So we've got those two regions where f is below g. The first interval, again, in terms of x values, is negative infinity up to negative 3. We will not include the negative 3 due to the strict inequality, and we'll union that with 1 to positive infinity. Part D is extremely similar to part C, but now we have equal to. So we can include those intersection points at negative 3 and 1. Negative infinity to negative 3, bracket, we'll union that with 1 to infinity.